Hello and welcome to another webinar. Today we are starting a new series with my friend and colleague Zsiga. We are talking about private cloud and data center architecture. This is just the first session from this series. We are planning to take you from, as we said, from zero to hero. This session we want to lay the foundation about data center, and maybe we'll touch base about how to connect the data center to the internet. We cover some use cases and some challenges. But before that, I just want to welcome Zik. Welcome on board, and thank you for allocating the time for us.
Hey, Mohamed, thank you so much. It's a pleasure as always. It's been a while since we put something together, and I'm really excited about this series, about today's webinar. It really gives a passion for me to teach and to learn new things.
Same here. Um, if we jump directly to the agenda, without further ado, so as we mentioned, today we are starting from the basics. So we'll talk about data center architecture. We are trying to cover one of the scenarios which are a bit challenging. If we have multiple data centers and each of them is multi-home to the internet age, what is the possible architectures and some design best practices. And then we will talk about how to control the traffic inbound and outbound of this data center. So before I will hand over to Zig. So let me give a quick introduction about our guest today and the co-speaker. So Zig has been working on the networking and this telecommunication industry and data center for the last 20 years. He's currently a customer delivery architect at Cisco, and he's an active CCIE, CCDE. He actually holds two CCIE certificates, routing and switching and service provider. Um, Zig, again, welcome on board. If you want to add anything, then we can jump directly to the fun part and start talking technically.
Yeah, of course. So I don't like to talk about myself, but real quick, right? So I have a whole bunch of certifications, as I'm sure a lot of you do. The most important certification is the CCDE, the Cisco Certified Design Expert certification. It's really just the most impactful certification I have. Not to downplay the rest, but it really is the most impactful certification I have. It really starts you to think about why we do what we actually do from a design perspective. So instead of just doing random decisions from a technology perspective, you're actually understanding why you're doing it. And then real quick, I love to teach, I love to learn. So you can probably find me helping people out, either study groups for CCIE, study groups for CCDE, really just teaching people content and technology. Today, I'm focused on business architecture. I don't know if you've all heard what business architecture is. I'm sure Mohamed and I will have plans to maybe do something along that in the future. But really, I'm focused on business architecture, and really at the bottom level, what that means is trying to map what a business is trying to do to the technology solution they're implementing. Vendor agnostically, we don't care about what vendor solution it is. We care about the capabilities that the business needs to be successful, which really transitions me to be a true why guy. I care about why a business needs to do something. That's enough about me. My contact's out there. You can find me on my website, on Twitter, on LinkedIn. Feel free to reach out to me anytime. Before I jump into the technical stuff, I'm going to go to the next slide here. I would prefer if this was a dialogue back and forth. So, you know, if I'm talking and Mohamed's talking and you don't have any questions, if you just be on mute. Otherwise, if you have questions, you know, come off mute, ask those questions, right? I want this to be back and forth. We're talking about something that's extremely important and imperative from a data center perspective today, okay? So on the screen, we have our initial kind of topology. And I like to call this the data center in a simple form policy topology, where we have a let's say one data center, and for me, I'm in the US, so we have a data center on the West Coast, like maybe say, let's say California. And normally when I talk about this, we have a data center on the East Coast in New York, because I live in New York. But for this, we have people on the call that could be worldwide, right? So let's say we have a data center in the US and we have a data center in Asia Pac. Maybe it's China, maybe it's Japan, or somewhere over there. Maybe it's where, maybe it's in Sydney, where Mohamed is. But they're geographically different, dispersed data centers, right? So here in this topology, we have our data center. Let me grab the highlighter real quick. So we have a data center here. This is going to be in our let's say US space, right? And then we have another data center that is over here, and this is going to be in our maybe Sydney or Melbourne area. Those are our two data centers for this kind of talk, and they're simplified, right? So you see 6 devices real quick. Obviously, our data centers are going to be more complex than that. They're not going to be just 6 devices or 2 devices in each data center. They're going to be more than that. But for our talk today, we're going to talk about just these 6 devices and how they kind of interact with each other.
If I may comment here, Zig, when we worked on this slide, building this slide, we thought to make it a bit simplified to make sure we can follow up and everybody will be able to understand. So this is just a simplification of a data center with showing one device in each layer, but usually you will have at least dual device from perimeter router, firewalls, and data center P and so on. Yeah, so go ahead, Beck.
Exactly, right? We remove the redundancy just because it makes it a little bit more complex, and honestly it clutters the screen a little bit, right? So we're trying to talk about this at a high level, and there's some words here that we'll talk about too. But again, in each data center space, we have a kind of an architecture. So let's say our first data center here, we have an edge router, then we have a firewall, and then we have a core router or a campus router. We have the exact same architecture in our second data center, and then we have some data center interconnects between them, or what I call DCI links or umbilical cord links between our data centers that really kind of tie them together. I will want to call out real quick these bottom routers here, and we'll get into router names on the next slide. These are our campus or core routers. And again, same thing as what Mohamed said, we're simplifying here. You're not going to have one router in your campus, right? Think of this as a pretty drastically big campus architecture or data center architecture, whatever you want to call it. We're focusing on internet connectivity today. How do you get your internet connectivity to the data centers? How do you get them connected? And then how do you ensure the traffic that's going outbound, egress, and then traffic coming into you, ingress, is going the right way? Because we can't even connect the cloud until we figure that out, right? So we have to build up to that process. Does that make sense to everyone on the call? If there's any questions, like I said, feel free to ask, right? So the first question I like to ask is, what are we going to do when we have 2 data centers? How are we going to get people to access our content, what we have hosted, right? So let's say we're hosting services. We have our servers, our applications, whatever, because that's what a data center's purpose is to host some sort of service or application. How are we going to get people to our application that's on-premise in a data center? And then how are we going to get our users and our applications going out to the internet, right? There's 2 questions that we have to ask in this architecture. So I tell people to deal with this question individually. Egress and ingress traffic engineering from a data center perspective should be handled in 2 different policies. So let's do egress, because egress is fairly simplistic in most cases. Here, egress, we could do something where we leverage default routes, right? That's pretty basic. We could go even further advanced into doing some sort of internet routing ingress. We could take all that internet routes that are out there on the internet. We could inject them on our edge routers, and then we could do some sort of funkiness. We could maybe inject every /4, every /3, every /2, or every other. We have a lot of options there from an internet perspective. But just to keep it simple, we could just inject the default route and then propagate that down into our data center and into our campus, so everyone knows how to get out to the internet. The real question from a data center perspective is, how do you get back? And there's a call out here that these firewalls, if you notice in the diagram, there is no link between the firewalls. They do not share state. Again, think of these firewalls as clustered firewalls in their own data center. There's redundancy, right? The icon is one firewall, but they don't share state between the data centers. So if anyone can think of that, right? A state device, when traffic leaves that state device, it must come back into that same state device. So even our egress, our default route going outbound works, but if they're going through that firewall, and let's say that firewall is running some state functions, how do we ensure that traffic comes back to that same firewall? If we're running NAT, as we can see here, there's kind of, if we're running NAT, NAT solves this issue. We call it symmetry of traffic return. So on these firewalls, let's say for IPv4, real easy, right? IPv4, we can run NAT on the firewalls. We're probably running RFC 1918, our private address spacing on the southbound end, right, of these firewalls going down. We're running NAT into our campus. Maybe it's, a 10.4.0.0/16. Maybe it's that big /16 range. And that firewall is NATing all those private ranges to a public range of some sort that we have from our provider. Maybe it's our own range, right? With NAT, what we can do is we can take our external block. Let's assume we have a /16 that's highlighted here. Or if you are running IPv6, you might have a /44, right? So if you're familiar with IPv6, you might have a /44. What we can do here is we can say, let's split up our /16 range into multiple slices, if you will. So instead of having one /16, maybe we have two /17s, or maybe we even go further, we do 4/18, something along those lines. And what we do then is we say, hey, firewall A here in data center 1 is going to own that first /17. And then firewall B firewall B in data center 2 is going to own that second /17. And that is how we can maintain state with NAT. NAT is very easy here. Any questions on that?
Maybe just highlight some points, Zig. So we are just taking one example of data center connectivity to the internet. We didn't talk about the simple, maybe single router connected to single ISP, dual connection from the same ISP to the same device. So here we are trying to discuss the design for the most scalable and high available solution. So this company is very critical. The services in data center must be always on. They have their own public IP. They have their own autonomous system number. So they have decided to go with two different ISPs. So, and Zig highlighted some challenges. So how to assure, maybe one solution would be just, let's assume ISP A will be always on and the second will be just backup. But we're trying to achieve the best. As we mentioned, we are working as a business architecture. So we built all these resources, all these links and devices, and we don't want to keep them idle, just waiting as a backup. So data center in the east, just being a backup for if we have any problem in the data center in the west. So we are trying to achieve multiple things. We are trying to achieve high availability. We are trying to achieve utilization of all our resources. And maybe my first question, which may be simple, but let's discuss it. Why in such a scenario we have to go with BGP? Why can't we use, as example, OSPF or even static routing between our multiple data center and the internet?
So those are some great questions, right? So let me just step back. We didn't get into even what the model is for our connectivity to the internet, right? So I was that first slide that I was just going over is really just a quick, hey, this is how we would do our design from a firewall state perspective for IPv4. But that doesn't mean that we would have to do an active standby between our ISP-A and our ISP-B here on this new diagram. It's a little bit more inclusive. So, we have these two links, right? We have a link to ISP-A here, and we have a link to ISP-B here. And again, think of it as they're two different data centers down here, and they're split geographically. So we have options, right? So that's the first thing. We can do active standby, right? And it's Really easy to do that. You can do local preference, you can do ASPath prepend, right? And we can talk about that at length. We can do some additional stuff too. There's Cisco proprietary, there's weight, there's a number of features that you can leverage and attributes to enforce an active standby. There's also active, which is something I prefer. If I'm going to spend money on my links, I would prefer active, right? I want to use that bandwidth as much as possible. But again, just because I prefer that, that doesn't mean that's what's needed for the business. So really it comes down to, does the business need active? Do they have a congestion issue, meaning they have 100 meg links, and if they go active standby, they're going to use that, they're going to, hit that top end of that first link at 100 megs. So maybe they need to use both links because they're doing more than 100 megs of traffic outbound or inbound, depending on their use cases. I prefer active just because I'm going to spend money on a link. Why would I not use the link? Of course, active is a little different, right? So I was talking about splitting up the IPv4 ranges, so that /16 splitting up into two /17s from the firewall perspective. So you'd have those two /17s. And what you would do there is the first /17 would be advertised to ISP-A only. And then the second /17 would be advertised to ISP-B only. And then our R5 and R6 here would advertise the /16 to both providers. Can anyone tell me why we would want to do that? You want to take a guess?
Yeah, I think this is needed in case of you have a failure in one data center and you want to redirect the traffic to the other data center using the DCI link.
That is perfect. Yep. So just like you said, right? If we only advertise the /17s, R5 to ISP-A and then R6 to ISP-B respectively, if one of them fails, that whole /17 is now black holed. That traffic doesn't know where to go back. So we have to advertise that /16 to both providers. And what we're leveraging there for our kind of traffic engineering, if you will, is really longest path, or longest route match, or longest match, right? We're not even using a BGP attribute. We're just advertising a more specific path, a /17 or a /18. And then if for some reason R5 does go down, we have a failure situation, or this link to ISP-A goes down, we now have R6 advertising its /17, but then also the full /16. Right? So then I didn't say before here, but real quick, these two devices have an iBGP neighborship between them. You could run IGP if you really wanted to. Here, I prefer iBGP. It is really a design decision. There's some things that you get when you run iBGP between these devices. They're already running BGP. Go ahead.
I'm sorry for cutting in. I just need to ask something. I mean, these are two different data centers, but what about the loads, the services themselves? I mean, because you just said that we are announcing the /16 for both of them to cover that failure scenario when one of them fails. So, I mean, if I'm destined to a specific destination, does this live in both data centers, or does it just live in one of them? Like a server that has a specific IP address, does it live in both of them? You can just like shed some light on the services and how do they exist inside these two data centers?
Yeah, so that's a great question. So, and honestly, it depends on what you're looking to achieve. You can do IP mobility between your data centers, right? So you can have a server live in both locations with the same IP. And there's technologies out there today that allow you to do that. There's also, I would call maybe potentially a legacy way of doing it, where you have a dedicated range, subnet range in each data center, and you route traffic based on that. And then you do some sort of replication between each data center and potentially load balancing or active standby with like a load balancer, right? So there's a ton of load balancers out there where publicly it's one IP for that application, but then internally it's, there could be 7 or 8 servers behind it, right? So me personally, I prefer doing the load balancing method. It's what I've known to work most of the time. I mean, I haven't really had a lot of issues with that. So let's use an example of an application. Let's say maybe give me an example of an application that you would leverage. Just so I.
Well, I mean, anything of satellite, for example, Exchange, for example, or maybe like
Exchange, right? So email, right?
Yeah.
Yeah. So email, like let's assume we have email and we're hosting email in both data centers, right? And then I would use a load balancer, right? And there's a whole bunch of vendors out there. I'm not here to talk about the vendor load balancers, right? I would use some sort of load balancer that externally to the internet, there's one IP or two IPs at most that get to my exchange. And then there's load balancers out there that will actually automatically rewrite DNS for you. So if one of those nodes is down, one of those VIP virtual addresses are down, let's say we have an address over here that's just for simplicity is .1, and then over here happens to be .2. Sorry, that's probably a bad example. Let me erase that. Again, in this example, we have this external range, this 128.4.0.0/16, and we're going to split that up, let's just say, with 2/17. So let's just say, because I'm horribly at writing with a pen on this, let's just say we have 4.0.1, and then I'll do my best to write the other one. Let's just say this is going to be 128, the third and fourth octet .1. Hopefully you guys can understand that. That's just the other /17 real quick, right? So this would still be 128.4.128.1. And over here, do 128.4.0.1.
Yeah. Yeah.
So let's say that the exchange lives on both of these subnets, right? And then the load balancer can round robin between them if it wants. It can do active standby, right? Same concept as our internet conversation, active standby, load balancing, round robin. And that's really dependent on the business, right? That what they want to achieve. I've seen load balancing, active work. I've seen round robin work in this fashion, and that's specific to Exchange too. I've seen it work for both those. What you get with those load balancers is that they're going to have health checks to these addresses, some sort of health check to make sure it's up and online. And then if it's not online, it's going to bring down the address. So let's just say there's a health check and says data center A, that Exchange node goes offline. So it takes this and it just says, hey, that's offline. It actually can update DNS globally on the fly and say, hey, this is no longer mapping to our Exchange DNS record, whatever that might be. Maybe it's webmail.fqdn.com or whatever it is, or I'll say email.zigbits.tech, my domain name, right? It automatically will update that, remove this one from the record, and this one is still in the record. So everyone's going to see that. Now that's externally. That's at the external layer. Internally, this address actually maps to maybe 7 different IP addresses.
Yes.
Right? Like this pool, this VIP maps to a whole bunch of different IP addresses, and I can't write very well with this pen, so I apologize. But you could have 7, 8, 10 IP addresses behind this one IP. And the same thing over here. You could have a whole bunch of different IP addresses behind that one IP. And the reason why I highlight this, I prefer this because this works in any data center architecture. You can do a layer 2 mobility architecture, or you can do a separated layer 3 architecture between 2 data centers, right? This load balancing mechanism here lets you have whatever in the data center space. If it's, we haven't gotten into like spine leaf architectures and, VXLAN between data centers, etc., which we do intend to get into. Did that answer your question at a high level?
Yeah, it's great.
Yes,
great question.
Yes, it's great. Thank you very much. Thank you, guys.
Yeah, I just want let me summarize because I enjoyed the discussion. So here we jump from internet connectivity to how to provide services, and I agree with Zig. And even in one of our sessions, we thought when we were preparing for the next session, we said we will discuss DCI, we'll discuss IP mobility like Lisp, like EVPN, all other these ideas. And Zig actually choose a very simple but powerful design, which is used a lot for many data center. I did it myself a lot, having this load balancer, which will give you availability and assure loading the share between multiple data center. And also this load balancer, usually they have something like global site selector or whatever F5, they call it GTM, to check if the load balancer itself on each of these sites is active, not only the server, but also the load balancer. So, but for the world, you're just announcing, advertising this URL, and the intelligent is in the load balancer. They decided what is the IP to map to the to this specific service. Maybe on the next slide, sorry, in the next sessions, we can talk about Lisp if we can have same IPs, which will be available in two data center.
No, exactly. I wanted to just call out one last thing too. So what I like about the load balancer design here at a high level, right, is the flexibility you get from an architecture. Because like we talked about having these VIPs, these virtual IP addresses in two data centers, right? But as we have that cloud conversation, we have these two physical on-prem data centers. What if we move our application to the cloud, right? Let's say we move that application to the cloud. We have this cloud, right? Redundancy there, cloud. Well, what if that application now has this IP address, 55.1.1.1? It's just a random IP in my range. We could easily put that in the load balancer, and now we can automatically redirect traffic via DNS queries to cloud, right? So you could provision your application if it's Exchange or whatever, if it's a SaaS application, it's a custom built application. You can literally push it to cloud, build it all out, get all the back-end services up and running. The database is replicated, however that might be. And then you just give it another IP and you put it in your load balancer. And now the internet can access. Now your users can access it. You can access it. And then once you start doing this, you can start potentially getting rid of your data centers if you wanted to, right? You may not need two on-prem data centers anymore. You might need just one if you're running everything in the cloud. That kind of goes a little bit further than what we're going to discuss today, but I think that's a great example of how that's a great example of how the load balancers give you flexibility in this architecture.
Yeah. Great thing. Nader, he was going to had a question just to confirm. Sorry, I cut you, Nader.
No problem. I have actually two questions. First, I think we should it's maybe early for this part that for DCI links, I think we're missing a third DCI link between like the corporate and corporate. So like one, you're mentioning there is one DCI link between R5 and R6 for the internet access, and then maybe another one for DMZ. And I think you should have another one DCI link between the inside area, or you're gonna use the DCI link between R7 and R8 for the traffic for both of them, both for DMZ and intra side traffic.
So that's a great question, right? And comment. This is a very simplified design. It doesn't show a DMZ. You could easily add a DMZ, right, and have a data center interconnect. On the next slide, we're going to talk about these data center interconnects at a high level. For this architecture, there's just, it's a quick, simple architecture. There's no DMZ. Again, you could easily add a DMZ. If you didn't have a data center interconnect for that DMZ, you could tunnel across the core DMZ or data center interconnect, or you could tunnel across the edge. I probably wouldn't tunnel across the edge. I probably just initially thinking on the spot, I probably tunnel across the core. That's just me. That's my initial gut reaction. Again, keep in mind, and I'll just go to the next slide so you can see what I'm going to talk about here. So my point that I want to make here is these data center interconnect links that we were highlighting a minute ago, they cost money, right? And a lot of times when I've gone to a customer and a deployment like this, they just can't afford these links. They're not cheap. So you can't have, here we show two of them, right? And they're not going to be cheap. What if you want a third or fourth or a fifth, I have seen organizations have 8 data center interconnect links. And when they are like $4,000 a month, I mean, that adds up quick. They're different depending on how far those links are. Again, our examples, California, West Coast, and then somewhere in Asia Pac, maybe Sydney. That's a really, really geographically dispersed data center connection that you need, right? So again, is that going to be dark fiber? Is it going to be L3 VPNs? Is it going to be L2 VPNs? All these options come up. So on that topic, what happens is I get asked this question, what if we don't have this link? You need the link for a lot of our solutions. You need this data center interconnect link, specifically this edge one, right? We're sharing our routes with it. There's a lot of techniques that we haven't gotten into regarding route manipulation and that we haven't even talked about today. And we can talk about that in the future as well. But we need this link. And if we don't have this link, here's the possible workarounds at a high level. And there might be more workarounds, just so we're clear. There might be some more workarounds. These are the workarounds that are most common. GRA tunnels to the internal DC core, right? We just kind of talked about that. And I would do the same thing for that DMZ. I do some sort of GRA tunnel. I would not put my DMZ traffic right on the core, though, or right on the edge. Because again, the whole point is your DMZ is a secured location. You're doing something specific. You have this place in the network where you're putting services and you're making them secure but accessible to the internet, right? That's at a high level what a DMZ is supposed to be. So I would use that DMZ and I would either do some sort of tunneling in my core campus or some sort of tunneling on the edge. And these are the options, right? We could do the GRA tunnels. We could do an L2, L3 VPN service. Or we can do an overlay over an existing L3 VPN, which actually becomes something a little bit more complex called carrier supporting carrier. Right. So, did that help a little bit?
Yeah.
Your question?
Yes.
Any other questions?
Yeah, I have another question. Maybe make it more complex, which is like if you are deploying DMVPN over the same internet connections. How can you segregate between, I know that you can segregate the traffic, but how can you pass this segregation over the multiple firewalls to connect to the, directly maybe to the inside network?
Yeah, so if I go back to this diagram for that to try to answer that, right? So you asked a question that I've actually done in real life. Now, I'm not saying this is the best way of doing it, but it's what I've done. Traditionally, when I run DMVPN across, let's say, my data center, so I'm going to have a hub routers, right? I'm assuming you guys have an understanding of the technology of DMVPN, right? But so there's going to be a hub router. Let's say there's a hub router. That's a square. It's not a router. That's not them. You can't use squares for routers, right? So let's say this is our
Cisco hit it. Yeah. It's have to be a circle.
And then we'll do another one over here. And my circles are horrible. See, that's why I went square, because my circles are horrible. Let's just say this is hub 1 and this is hub 2. Again, sorry about the handwriting. It's atrocious. So hub 1 is in data center 1 and hub 2 is in data center 2. And then let's assume you have some sort of connectivity here to a remote site, right? This is some sort of remote site with someone working on a computer over here, hanging out, doing their work. And maybe we have another remote site over here with a router, computer, switch. You get the idea, I think. And this is a really bad architecture design. This router would actually be dual homed, right? That's the idea behind DMVPN. So we'd have a connection there and a connection there. We have a connection there, something like that, right? High level. And then we have our hub routers connected to the corresponding data centers. So the first thing in this architecture, right, my hubs would have a dedicated range. And I would have to make this decision. I would want them to be active. So I'd want to have the same, whatever network that I provision for my spokes would have to be active through back into my core routes, the tunnels that are created. And I would ensure my services were what really matters here, right? So I don't care per se how my clients at each site necessarily route their networks themselves. So like whatever range we give these locations, I don't care if they prefer ISPA's tunnel through R5 or if they prefer ISPB's tunnel through R6. I don't care which hub they hit, honestly. What I care about more than anything else is where they're accessing their services. So I would do some sort of traffic engineering on my advertisements of my core networks. So again, we're talking about splitting up our ranges here. The external range, we have this /17, but also for the internal range, we'd have a /17. So this 10.4.0.0/16 I'd have 2/17s or again 4/18s. And as I advertise those to the hub or whatever through the tunnel, I would prefer those across ISP-A's tunnel and de-prefer them over ISP-B's tunnel for things that live in data center 1. Does that make sense? To answer
Yes.
your question. Because again, what is your spokes accessing, right? What are they accessing? If I make everything else equal, as ECMP, right? Equal cost multipathing. What really truly matters here is you need to get to a service that's hosted behind one of these data centers. And so I care about which service you're accessing, right? And I want to make sure you go through the right data center firewall. So a firewall 4 or firewall 5, whichever one hosts that content today, has those NAT statements and those state tables, right? I need to ensure that your traffic is going to the right firewall and then not going across ISPBs, either hitting firewall 5, that's going to get dropped, right? Firewall 5 does not have that state table. Or the other option would be hitting R6 here and then going across this link to R5. And that's not what we want. We don't want to leverage that data center interconnect link if we don't have to.
Yes.
Yeah,
I want to keep the traffic local because this link is very expensive, and usually we want to minimize the traffic passing this, as we mentioned, interstate or even international IPCL link. Go ahead, Nadria.
Yeah, so I agree, but I have a question, another question on DVPN. Will you, from routing perspective, maybe I'm jumping to maybe to the next slide or something, but usually like the easy thing to deploy the DVPN is EHRP. So you're gonna have EHRP deployed maybe between the remote sites, and then you're gonna have BGP on the data center side, or you're gonna have running something different, because the EHRP routing can't be passed to the R7 or R6 because they are multicasting.
All right, so here I'd run a BGP, right?
Yeah.
It's my edge, right? And I'm actually running eBGP to my provider, right? I'll talk about it because I hate writing.
Yeah.
And I'm running iBGP to my neighbor R6, right? And R6 running eBGP up to my provider. Something I didn't talk about at the beginning, and I'll just highlight here. There's different designs where either you own the firewalls. So a lot of my customers will not be able to own their firewalls. Okay, so they have a network team and they have a security team. So the network team owns the routers, the security team owns the firewalls. So when that happens, traditionally the network team is not allowed to run routing on the firewalls. So in that case, this architecture design, if I could run an IGP here on these firewalls, I would, right? I would. I'd run BGP here. I'd run an IGP on the inside of my edge routers going down to my campus core. But if I don't have the ability to run an IGP on my firewalls, I can run an eBGP multi-hop section to R7. And same thing on R6 to R8. I'd run an eBGP multi-hop, right? Because again, these are routed links between R6 to firewall 5, and then firewall 5 to R8. These are routed links. They're not a layer 2 link. It's not a bridging of the networks. It's routing between them. If I run that eBGP multi-hop, I can share routes to R8 and R7 to my campus. Now, what you do there is up to you and what you're looking for, right? It's all dependent on what you want. So you can run an IGP here, right, on R7 and R8. Again, R7 and R8 are placeholders for a campus or core or that data center architecture, right? That huge data center architecture. You can run an IGP, you can run EIGRP, you can run OSPF, whatever is your fancy, right? You can run BGP too. You can run BGP like IGP. It really depends on what you're trying to get out of it. In a perfect world, if I had a choice, I probably wouldn't run BGP in my campus unless I was doing like a spine leaf architecture. And if I was doing like a spine leaf massive architecture, I'd probably be using private ASNs across different data centers and then doing eBGP, not iBGP. Because can anyone tell me why I would want to do eBGP over iBGP? Anyone want to take a guess?
because of the firewall, I can't pass normal IGP traffic over the firewall.
No, maybe.
Actually, I feel this problem in one of my projects that because of the MVPN we have AGRP, we couldn't pass this traffic over the firewall because of the firewall doesn't allow multicasting, and the firewall security people doesn't want to have multicasting enabled over the firewall. So we had two choices. Either we can use BGP and they allow the two ports for them, or they're gonna put some static configuration on the firewall.
Yeah.
Yep. So that's a good point, right? Some firewalls and most firewalls don't allow multicast. So we're potentially stuck running BGP, and on the firewall we're doing static routes, right? And I call those static routes tragic routes. First off, if you're doing a static design, it's tragic. You're never going to be dynamic. It's never going to change. It's never going to adapt. So just if we have to do static routes, we have no choice. Then we have no choice, right? I prefer to deviate and do dynamic protocols as much as possible.
Yeah, I agree, but security people doesn't like. I don't know why, but security people doesn't like do any routing on the firewalls. They're gonna be out of the control, and CPU perspective, they're gonna consume part of their CPUs.
Exactly, and I get that argument all the time, right? All the time. And that's why this is actually something that I highlight in my Cisco Live presentation every year. Because again, these firewalls, in most cases that I've talked to customers, they're not owned by the network team, and you can't run a routing protocol on it, right? So what do you do? So again, you're stuck with BGP, right? And you're right, that's why we leverage BGP, but you can leverage eBGP or iBGP here, right? You don't have to leverage eBGP. And the question I'm really asking here is, why would you choose eBGP over iBGP? And I'll answer the question real quick. So my decision would be, do I need more control, right? Do I need more control of my routes and my paths in BGP? If I do, I'm going to leverage eBGP. I have more policy control with eBGP. iBGP is technically more simple. It's simpler, whatever the right wording is, right? iBGP is more simple or simpler. eBGP is a little bit more complex because you're running policies, you're running eBGP neighborships. But again, you have that flexibility with those policies. You have more control with your policies. You don't have as much control with iBGP. Does that make sense?
Yes, it's actually very interesting, Zig. I want to make sure that everybody is able to follow us, because the scenario which Zig's presenting now is not really, you will not see it in any small company. So here, I believe most people may see that they have, in the internet age, they have full control. They have a single IGP running between all their layers, so they can exchange routes easily within their network, internal network. But here, what we are trying to highlight, this is a huge corporate with very large data centers. They have multiple teams, and they have what we call it least privilege, or they have different teams managing different part of their network. So even we're talking with Zig earlier that even the internet layer, if it's available in multiple countries, as we mentioned, one data center in Australia, another data center in the US, maybe each one of these data center will have its own BGP autonomous system number. So it's not something like written on a stone that if you are within one company, you should have a single autonomous system number and just dealing with the whole world with this only autonomous system number. Autonomous system is built to identify or to do like your administrative boundary. So even within one company, a single company, you can have multiple BGP domain. And I agree with Zig, it will give you much more control, because eBGP neighbor, as we know, it changed the next hop. It's treated differently. You have a lot of modification to the send and receive. You don't have this problem of iBGP that that you cannot send the traffic, the route learn from one neighbor to another without route detector and so on. So just to summarize, this situation, we don't have a single IGP in the network. Consider like we have one layer of BGP as edge, and another layer which router R7 and R8, and in between we have this different, considered like third party, not managed totally by you, which is firewall. So how to make sure you deliver your traffic over this black box, which firewall, the maximum thing that you can have is having like just static routes from R7 to R5 and so on. But then you need to play with BGP to make sure what services to be advertised to the internet, as Nader mentioned, DMVPN, how to terminate it, how to assure it will reach the most suitable or the closest exit. Yeah, back to you again, Zig. So everyone just want to confirm, are you following? Do you have any question? Do you think this is something you saw in real life or?
This is fun. I'm good here. Everything is clear so far.
Great. Thank you, Khalid.
No, that's great to hear, and thanks, Mohamed. So that's great clarification as well. You know, we went from a small architecture to a very large architecture, and obviously the diagram here, the topology doesn't show a large architecture on the fly. I know Mohamed just asked, but are there any additional questions?
Let me take it to another angle. While you're talking, you said we have to control the egress and ingress traffic. And actually, you choose the best way, which I always prefer, because when you talk to some engineers, they don't have maybe the why, or they're still learning BGP, and you tell them what is the best way to control the egress traffic, maybe they will say wait. And we have Cisco proprietary as example, but we have multiple ways. We have wait, we have local preference, we can set a community, and based on this community, the upstream service provider can control it. And we have, for me, we have the most assured way. You have the full control when you have using the longest match. So can you just in 2 minutes quickly touch base on this different option, and later on we can discuss how to also control the ingress traffic, which somehow little bit more complex.
Yeah, so egress, right? And the way I like to break this up is two different processes, two different thought processes in your head, right? So egress, traffic going away from us, going outbound. We actually have to inject routes to us. So it's counterintuitive. And I try to explain that as much as possible in my Cisco Live session, that traffic going, our traffic leaving us, we actually have to modify or inject routes from our ISP into us. We could do static routes, right? We could do a static default route, but we're not talking about that. What we're talking about is taking routes from an ISP connection into our edge router. And what routes do we take and why? You know, 20 years ago, when I was brand new in the networking industry, I was like, I need the full internet table. I didn't have a reason why. I didn't have a reason why. I just wanted the full internet table on my edge routers. I think back then it was like 300,000 IPv4 routes. So my edge routers were built up. They had all these routes, and I was like, yes, routes. I had no actual business justification to receive the full internet table. Today, I would ask why, right? And what are you trying to accomplish? So most times, I would say 9 times out of 10, I just receive the default route. There's no reason to complicate it from an egress perspective. Now, if you're going to do some sort of active architecture policy, then I would receive a default route on both of your provider links for both policies, so R5 and R6 respectively. I'd receive the default routes here and here. But then R5, what I would also do, again, this is assuming that you want to do active, I would take the full internet table out there. And if you don't know what that means, I don't have a slide here handy to show you, but I do have it in my Cisco Live session, so you can always look that up. It's BRK RST-2044, and it goes into a whole bunch of detail on how to identify the full internet table into chunks, into slices. So what I would do in ISPA, my policy on R5 would say, I want to receive every other /4. I'm literally going to split up the internet table. I'm going to take every other /4. I'm going to inject it into my BGP table in R5. And I'm going to drop the rest. I already have the default route in there. Now I have half the internet table routes on R5. I'm not going to do anything else. I'm not going to change local preference. I'm going to go ahead and inject those in R5. Now on R6, what I'm going to do, I have that default route. I don't need anything else. I'm going to go ahead and increase my local preference on that default route so that when that gets passed between R5 here and R6 to R5, that default route is going to get shared here, that IBGP link. Its local preference is going to be higher, and R5 is going to choose that default route over its own. And what that's going to allow us to do is our outbound traffic is going to hit R5, and if it's a route that is known by R5, it's going to go through ISPA, every other /4. If it's a route that R5 does not know, then it's going to go across this link to R6 and then out through ISPB. And we're going to theoretically split the entire internet table that way. Does that make sense at a high level for egress?
Yes, it makes a lot of sense. But usually there's a lot of arguments in the market that if you are a big corporate and you have a lot of data centers, with many of them having internet gateways, maybe at that case, you need to have full routing table just to make sure you know that what we call it cold potato or hot potato, you want to use your internet efficient, the most efficient way. So maybe at that very specific case, you will need to have the full routing table. But back to our scenario, and I have a comment to you, Zig, and we can discuss it with our colleagues here. Let's say these two, both ISP-A and ISP-B are in the same country. Let's say we are in the US. We are taken from Verizon and AT&T. And for sure, each one of them, they have a lot of what we call it other autonomous system number, which is directly connected to each of them. So let's say in ISP-A, we have company X, Y, and Z. And in ISP-B, we have companies A, C, and D. They have the public presence as well, but they are connected to a single ISP. So do you believe usually it's a good idea also, plus the default route, that each of these service provider will send you the local directly connected autonomous system number? So this will help you also to get to this autonomous system the fastest and the most efficient way. So have you seen this, and what is your comment about this idea?
Yeah. So great question, Mohamed, right? Again, when I was just highlighting as a very simple way of doing this, and that's because there's no business justification to do anything else. There's no need to. Now, there's other options with your ISPs to receive different routes, right? You don't have to just receive the full internet table or just the default route. Those are two different extremes, right? You could just get the default route or you get the full internet table, but there's a whole bunch of things in between that. There's local routes. So your ISP is going to have its local routes that you could just inject. So R5 would get those local routes, and then it could prioritize anything that ISPA learned that was local out through ISPA. It might be quicker. It might be faster that way, right? There's also provider routes. So there's something called provider routes, customer routes. So local routes, customer routes, and provider routes.
Yes.
Those are all options that you can do. Again, those are conversations with your provider, though. Some providers offer those and some don't. There's another option, too, that we haven't gotten into is like community values, too, right? So your providers could be leveraging community strings, which you could actually, maybe community string is the wrong terminology, actually, but a community value that lets them manipulate your routes or manipulate routes being sent to you. And that's really a conversation with the provider. Go ahead, Mohamed. Sorry.
No, I just agree with you that now a lot of these service providers, that upstream service provider, they have like a community book or community booklet, whatever they call it. And they tell you, as example, if you have multiple links with me and you want me to prefer traffic coming from this link, please use community XXX 100. If you want to make it less preferred, use XXX column 1000 and so on. So you give you flexibility to also enforce the ingress path. You remind me of one scenario which was really irony and different. Usually the ISPs in each country, they have what we call it a peering. So usually if to get connection from a service in ISP A or ISP B, usually it's just a matter of a couple of milliseconds. So it's not really the end of the world. But what I saw when I was working in a couple of service providers in the Middle East, they have two service providers in the same country, but they refuse, part of the competition, they refuse to peer with each other. So the only peering for these ISPs in this country in the Middle East was in London. Can you imagine? Wow. So if you are in service provider A and you want a service in ISP A, your customer there, and you want a service in ISP B, actually your traffic will go from Middle East to London and back. So almost 300 milliseconds. And we tried hard to convince them to peer with each other, but we failed. So in such a scenario, assuring your advertisement and the route that you receive will make a huge difference in your user experience.
No, exactly, 100%. So that was we were talking about egress, and you asked me to talk about ingress too. Did we cover egress enough? Is everyone okay with egress at a high level?
Yeah, just want to let me ask the audience. So now we talked about 4 options: most specific, local preference, rate, and community. Does anybody have any comment or any question before moving to ingress? If not, let me ask you, which one we talk about that maybe the most specific route is one of the best. So what is would be your second best, local preference or community?
So in my experience, I've had issues with the community. I've had ISPs or providers that will say they will adhere to a community value and then they don't, and it's been a process to call them up and say, hey, we have a contract and you didn't follow the contract. So I would personally prefer doing my own policies on my devices. 100%. Now, when you do that, you have no control of what they do once those routes leave, that path information. Once it leaves your devices, I mean, your providers can manipulate them, right? And it's very easy to do. They could clear the AS path totally. So if you're trying to do AS path prepend for our ingress policies, we didn't really get into ingress that detail, but for ingress traffic manipulation, again, that's traffic coming back to us, right? Ingress. We would have to actually modify our advertisements outbound, and that's where we would use AS path prepend to do more of like an active standby. And when we do that, our provider, let's say ISPB here, let's see if I got the pen here. So ISPB, let's say we're doing AS path prepend in R6, because we're going to say our connection here is going to be standby. This one's going to be active. ISPA is active, ISPB standby. We do AS path prepend, so we prepend our AS number here like 4 times, right? And on the advertisement of our network here, that 128.4.0.0/16 out to the internet. ISPB could say, well, I don't care about your AS path prepend, and rewrite it and just add 1 AS for our number, and that's it. You know, once that route leaves us, we have no control over what they do.
So
answer the question.
Yeah, it is. It is. Thank you for that, Zig. And actually, you touch base on how to control the ingress. So something stating the obvious. So usually you have the control traffic and the actual traffic. So usually based on what you advertise, you actually influence how the traffic, you will receive the traffic. So as Zig will explain, in order to enforce the ingress traffic to us, we need to play with some of the tools when we advertised our subnet. So I believe Zig, he talked about AS prepend, we'll talk about mid and maybe community. So back to you, Zig.
Yeah, real quick, right? We didn't get that detailed into it. So we talked about splitting up our ranges here, right? And we did talk about having our NAT pools on our firewalls. We did talk about having an eBGP multi-hop between our edge and our core devices. So first off, from a /17 perspective, our external range, we want to advertise it on our core or our campus devices. And the reason there's a failure situation, so I'm going to give you the answers here real quick. We want to advertise our /17 R7 and R18 respectively, because R5 and R6 do not have any visibility of failures all the way down to R7. So if we were to advertise our /17s on R5 and R6 into BGP, and firewall 4 went down, those advertisements would still go out now, right? So we want to have that control where if firewall 4 goes down or R7 goes down, sorry, one second.
Yeah, sorry guys, while waiting for Zig to come back, maybe because talk about Ingress and Egress, somehow maybe we make some
Sorry guys.
yeah typo.
No, can't control things from home. I apologize.
Never mind.
It's our normal lives nowadays.
Yes.
Sorry, Mohammed. So yeah, so here we were, right? We want to control the advertisement of that /17. So the failure situation here on R5, we were advertising that /17 on R5, and firewall 4 or R7 went down, R5 would still advertise that /17 and actually black hole traffic, right? Because it's sending it here, that return traffic would hit R5, and then R5 would be like, hey, I don't know where to send it. I don't know where to send it. So we want to advertise the /17s on our core devices down here. That's the first thing, okay? Now, when we advertise those /17s outbound, R5 and R6 are going to apply policies to it. And those policies are going to be dependent on what you want, right? If you're going to do active-active, you can just send them outbound, right? You don't need to make any modifications. You don't need to do AS path prepending. You're good to go. But if you do want to do active standby here, let's say you want those active and this one standby, that's where you would do AS path prepend, specifically on the advertisement from R6 going outbound for your /16 and your /17, depending on how you wanted to do it. Out on the internet, they would see these routes and they'd have multiple paths depending on how their BGP configurations set up. So they would see potentially 2 different ways to get to your /16. They'd see one through ISPA without additional AS paths, but then they'd see another one through ISPB with maybe 4 or 6 AS path hops. That makes sense.
Yeah. I don't know what happened, Zig, but your video freeze. Yeah, now it's back. Yeah. I was just going to say, maybe by mistake I mentioned that we use more specific to control the egress. Actually, I meant the ingress traffic. Another point, sometimes you heard about a very nice BGP feature or knobs, but you don't know a use case to use it. So let's say you're mute, Zig. So,
Yeah.
Yeah, I was going to say, let's talk about feature like BGP to control the advertisement. So in a case like this, if we have a device intermediate between R5 and R7, and let's say R7 they are responsible of some of the IP version 6, which doesn't need to be netted, and advertising some of these /64 directly to R4. And do we have something like we need to check if there is a link exists in the routing table, advertise this route. If this link disappear, don't advertise it. Something like conditional advertisement. And
you can do conditional BGP advertisements based on routes and the topology, right? So there's a whole bunch of options there. If you see a route in the BGP table, and depending on the code version and the vendor devices you're running, you could even do a conditional advertisement based on routes just in the RIB, so the routing information base, or actually in the BGP table. So you can check all those. And they're actually really, really slick. So if you're looking for a full range, maybe that /17 that we talked about, hey, if there's that /17 here, is in the table, don't advertise the /16. Or hey, if that /17 is not in the table, advertise that /16 outbound. To answer your question, Mohammed?
Yes, it does. So what about mid? Why mid is not a good option to force the ingress traffic coming back to you as a data center?
Yes. So med is not transitive, right? So what that means is that med's not going to be something that is adhered to once it leaves your ASN. So again, our ASN here, let me clear this again here. Oops, back previous. All right, so if I clear this real quick, right? We have our ASN here. So if we have a med value coming into us, we can make decisions on that med value here, and there's actually a design that we can do that, which works pretty well. And I'll talk about that in a minute.
Sorry, you're back.
Sorry about my dog, guys.
Yes, okay.
There's not much I
Just
can do
adding,
about my dog here.
yeah,
So-
the funny part to the session.
Yeah, the dog, he's my expert, he's my expert over here. He's talking about BGP.
Maybe he want to ask a question, or he doesn't like one of the tips about mid.
Yes. He's not a fan of med, so he might be ready to be done actually with me. So he's not really happy. I locked him in the office. So but this is our new life, right? This is how life is. So we can't get really mad about it. So med is not transitive, which means that if we had a med value on our routes on R5 here, and we sent those prefixes up to ISPA, the med isn't going to be received on ISP. It's different ASN. And depending on the vendor hardware you're using, the software, the med value gets stripped, reset. Some of them are still received, and then they're cleared on the after device. It really depends on the hardware that you're running in the code version. So that's why we don't use med at the internet edge here. Now we have an option down here where we could leverage med. So if we were running an IGP here, right? IGP, I can't write it very well, but if we're running an IGP here, let's say EIGRP, OSPF, whatever, we could inject those routes into our BGP configuration here, our eBGP configuration. He doesn't like this med solution, guys. I'm sorry. He just doesn't like this med solution. So we inject this IGP into the routes from IGP into BGP. And when we do that injection, we actually include the IGP cost into the BGP med value of those routes. And then that's sent up to R5 and R6 respectively. And then on R5, R6, we actually can tell them to always compare med. It's a keyword in BGP. We can say, hey, BGP always compare med. And now we can prefer the IGP routes or de-prefer them because we have that med value. We have that now. We can make decisions on them. This is very useful when we talk about IPv6 in this architecture, because IPv6 doesn't require NAT. So we're not running NAT on our firewalls, but Firewall 4 and Firewall 5 are still state devices. So because they're still state devices, we still have to return to the same firewall. So if we leave Firewall 4, we need to come back to Firewall 4. But without NAT, our symmetry problem is still there. So what we could do there is we inject that IGP value, that cost, the metric, I mean, into BGP's med. We compare it on R5, R6, and now R5 and R6 know how to get back to that IGP route.
Yes, 100%. So usually R5 will choose the closest with the lowest mid, and R6 will do the same. So we don't leave it for luck or leave it for other BGP selection criteria. So maybe in this case, if R6 want to go to R7 by mistake, he will decide to go to R5 and then R7 instead going directly to R8. Yeah, great.
Also keep in mind that in these conversations that we're talking about, these architectures, this data center interconnect link here is required, right? So if you don't have this, what we talked about today, you really can't do, right, at a high level. Now, there's workarounds that we talked about. We did highlight some workarounds, and they're on this page, right? So if you want to do some workarounds, these are the workarounds here in the bottom. They're not the preferred option. The preferred option is to have this link. But if you don't have the money for that link, or it's not capable in your area, maybe there's no offering, then these are the workarounds you can get. And you can get the same functionality and same benefits of the architecture and the design that we're talking about here with these solutions. It's just you're relying on your core link here, right? And that's fate sharing. If you guys don't know what fate sharing is, that means you're sharing this link isn't just a core or campus link anymore. It's now your edge peering link as well, even though it's not technically, it's running on top of it. So it's fate sharing.
If you lost this link, actually you lost multiple layers. So that is sharing. Yeah, they will share the fate about this link.
So if you lost this link, right, you would lose the connectivity obviously between your core, your campus, right? But then you'd also lose the virtual link here that you're leveraging over it. So you lose your actual data center interconnect link here that's a virtual, right? So any of your policies that are relying on that virtual link would go down, would not be would not work as expected.
Yes, usually when people talk about fate sharing, usually from traffic engineering, SRLG, share list, link group, always pop into my mind that if you have multiple links and you want to do the primary and backup, you need to make sure they are not sharing the same risk link group. Yeah.
Mm-hmm.
Yeah. Thank you again, Zig. Zig, before we wrap up, does anybody have any question?
Yeah, this is Aliu. Thanks, Zig, for this presentation.
You're very welcome.
Going on and added, or the network is already deployed using an L3 VPN connecting edge router, and this L3 VPN is used for DCI, is used for any external connectivity, going to internet or going to the WAN. And it's really a big concern because they're just using two routers using as a edge, and this edge are connected to the VPN, MPLS VPN for all services. So in this case, I guess, like you say, this is a fate sharing. What would be the design that you would advise for this part of the network? Is it to split the functionality, let's say, for internet and WAN on one set of routers, and for all other external connectivity on another set of routers, or to duplicate the links? What would you advise?
Yeah, so fate sharing situations. I think the first thing is understanding the fate sharing impact, right? And having that conversation with the business and validating, hey, is this okay? And if it's not okay, the business should be the one saying, hey, we don't want this. And then you can say, hey, here's the options, right? We could get new routers that are dedicated for this purpose. We get new links that are dedicated for this purpose, and you can outline the cost and all that and say, this is what you're going to get. And we won't have fate sharing anymore. But that's really, in my opinion, a business decision. And as you're going to be that person that's going to share that information to them. This is what you can do, and this is how much it's going to cost. And now you don't have that situation anymore.
100% Zig. And this is, as you mentioned, this is the business architecture. This is the real CCDE mindset, the why. So before decide technically, I think you have to ask the question, what are we trying to protecting? What are the services transported over this link? Will the customer just accept this risk? This is for them a low risk. They are not going to, as example, spend $100,000 to back up this link while the traffic passing through is just internet or peer-to-peer, whatever. So to come with the right decision, you need first to understand the business implication of this link, of losing the services which are served with this link. And then, as Zig mentioned, you come with multiple options, each option with the cost associated with it. And customer will be able to decide which one they are going to go with.
Okay.
That's well said, Mohamed.
Thanks. Thanks.
Any other questions, you guys? Well, if you guys have any other questions after the webinar today, feel free to reach out. I'm on Twitter, Zig_Zsiga. That's ZIG_ZSIGA. You can find me pretty much everywhere with that name, LinkedIn, Twitter, and then also my website, zigbits.tech. Feel free to reach out if you have questions. And obviously, if you need anything, Mohamed's available too. We're just trying to share this information for everyone to learn.
Yeah. So thank you again, Zig. Thanks to everyone. You actually enriched the session with your questions and with your comments. And as we said, this is just the first session. We want to lay the foundation about DC on the next session. As we discussed, we will cover DCI, we'll cover VXLAN, hypermobility, and then we reach the hybrid cloud architecture. So stay tuned, and I will share maybe by tomorrow. I will share the link to the video, the recorded session. So please spread the word if you like this session, and let us know if you have any question or any topic you want us to discuss in the future session. Thanks again. Have a good day, and see you soon.
Hey, thank you guys. Have a good day.
Great, thanks, guys.
Thank you.
Thank you very much.
Thank you, everyone.
Thank you, Mohammed.